Hello, this is John Zeman with TPM, the newer safety guy. I've been here 3 months and I've really enjoyed my experience so far. Um, this is March 19th, 2015. Today just happens to be my birthday. I just thought I'd let you all know that. And I get to spend it with you all. So I would like to start by thanking you for your participation. And those of you who may join us by viewing this at a later time online, thank you in advance for that. Today we're going to go over the topic of timber ergonomics, handling different wood products. We'll do a brief overview of ergonomics and then get down to some of the nuts and bolts of ergonomics as far as how we're exposed to the hazards associated with ergonomics and what we specifically do. All right, well, basically in a nutshell, ergonomics is making the job fit the worker. See the people here? I think these are graders, if I'm not mistaken. Ergonomics looks at the workstation, the tools, the motions, physical conditions, physical limitations, and the environment that we work in, and tries to make that fit better so we can increase production and lower the risk of problems with our employees. The problem that can develop from, say, the ergonomic hazards are musculoskeletal disorders. We'll use the abbreviation MSD. So some of the symptoms of MSD injury are dull aching sensations of the back and different appendages, discomfort with movements, tenderness to touches, burning sensations, pain, tingling, cramping. That all can be associated with musculoskeletal type injuries. And also stiffness. Common injuries include tendinitis, tenosynovitis, trigger finger, Raynaud's syndrome, de Quervain's disease, carpal tunnel syndrome. What introduce these types of injuries are the different risks to these type of exposures. So you have repetitive motions, you have awkward positions, vibration, force, twisting, bending, elevation of your arms away from your body, lifting. When you increase any of these variables, these factors, you increase the likelihood of an injury, and that's what we'll talk about today. So the workplace risk factors are tools that we use, continuous contact, restricted clearance, improper seating and support, and bad body mechanics. Certain things are designed a certain way and we move our body to fit the job. And that's where a lot of these problems come from, when we try to fit our body to the job, not the job to the body, especially if the job is old and it's been around forever. Maybe it was designed with production 100% in the forefront, and we just dealt with the ergonomics as an afterthought. So let's identify some of the risk factors, and the ways we can do that are management, employee communication. If someone's telling you, man, this hurts, I do this for an hour or two, I hurt. That's usually an indication that something's going on and we need to, change something. Audit workstations. I've been trained specifically to go and take care of computer workstations, look at different job workstations, look at the job movements, the frequency, because those are the three factors we always want to look at: is the force that's used, the body positioning, is it awkward? Is it designed for the human body to do? And then you have to look at the repetition and the frequency that it gets done. And then, we audit these procedures, and then we can kind of break those down and to try to figure out, well, how much, it's a risk factor, but how hazardous is the risk factor? And that's what we can determine through these evaluations. As with anything in safety, some of you I've talked to, the theory of safety usually can be broken down into these types of controls. Once you identify the hazard, you can work on the controls. You always want to start with engineering controls as the forefront, because that will totally remove the hazard or reduce the risk within acceptable levels without having to worry about people wearing PPE and that, because that can always be worn incorrectly and all that. So you look at workstation design, tool design, equipment design, and can kind of identify, well, these are the things we can permanently change in the workplace that can reduce or eliminate the risk and the hazard to a musculoskeletal type injury, an ergonomic type injury. Some of the tools, I put these pictures of elephants here because those are tools, a living tool, right? Instead of the guy lifting the wood, he's using an elephant to lift the wood. I just thought that was kind of interesting. Using animals to do things for us, I guess. Now, we don't even hardly use horses anymore. So, looking at the tools and how they fit the job, our basis for engineering controls. And then you have workstation design, provide adequate workspace, work height, support, storage space, so that everything can kind of fit together in a very usable and efficient manner. And efficiency is not only production, but also efficiency on our most valuable resource, and that's our employees. We don't want to wear them out, and then that that leads to an injury. So let's look at the workstations. We want to reduce loading, raising and lowering working height. Remove hard or sharp edges, because when you have a sharp edge, you press your hand on, it restricts blood flow, and then that can lead to a lot of problems. Provide mechanical advantages, insulate heat and cold. These are all different factors, that going outside the normal strike zone of the body and moving away from that can increase the risk of injury. So as you look at the workstation, can we provide some seating or some support? This is a picture here is an example of a leaning chair. You lean up against this, and it takes a lot of pressure off your lower back and your hips, your knees. So you can you still do the job. You can kind of lean on this chair. It's kind of a neat deal. A lot of standing work positions will use this just to kind of get a little alleviate some of that extra stress on the body. And improve material orientation. We'll go through a lot of details on it. Material orientation, as we're moving the material handling of our wood products. And then just improving layout. Look at how people move. I've been in a few different sawmills. I sit in our stand and watch a job get done, and you start thinking about, well, why is that way over there? Why is the controls way over here? Why, so people are having to move further to do things, and maybe we can move it and orient it to minimize the movements, to make them closer to the center line of the body, so you're not extending and putting yourself in awkward positions over and over throughout the day, because those will wear you out a lot quicker. So improving the layout will do that. Tool selection, look at the gripping on, they talk, this is one of the big things with ergonomics. Everybody, ergonomic screwdrivers, ergonomic hammer, ergonomic tools. Well, that's what they're talking about here is, how are these, there's some neat hammers out there. It's a crude example that are angled so that when you swing them, your wrist doesn't take all that vibration and all that damage to it, because it moves the kinetic energy through your arm and displaces it, so it's not so pinpointed on your wrist that can create problems. Excessive grip strength. A lot of times the smaller the handle, the more grip strength you need, so you can make bigger handles. I don't know if you guys have driven cars that have big steering wheels versus skinny steering wheels. The bigger steering wheels over time usually are a lot more comfortable, and the same thing goes for tools. The bigger the handles are, the less force a lot of times it takes to grip them. You don't have to close your hand so much around them. And awkward positions. We'll see later in this presentation where using your hand is one thing and your arms to lift and move pieces, but if you have to bend your wrist and then use your hands, it reduces the amount of time that you should be using it, before you get exposed to a injury, because the more you turn your wrist, the more force it takes. I don't know if any of you are listening. One thing you can do is you can hold your arm out in front of you, and you can put your hand over the outside of your arm. So say you hold up your left arm, you take your right hand and you put over your left arm, kind of right down from your elbow. And if you close your fist, you'll feel the muscles move a little bit. But if you crank your wrist upward and point your fingers toward the ceiling, and you close your fist, you can see the muscles retract and constrict with a lot more intensity. So that's why those angles are so important. The more you're away from a neutral position, the more that it takes more force it takes. So then more force, more trauma to the muscle, leading to injury. And then repetitive motion. So the more you do something in a given amount of time, the more you break your body down, the more it leads to injuries. So the next thing, you have your engineering controls, and the next one is your administrative type controls. And that usually begins with job rotation, shift length, overtime management, rest or breaks between jobs, and those all lead to your production rates. And we'll get into a little more in depth of the job rotation, shift length, specifically on some of the jobs that we do. The bottom line is your job rotation for ergonomics is the same for respiratory, the same for hearing, for noise exposures. If you can kind of average out the exposure, you greatly minimize the daily exposure. So when you move someone to use different muscle groups and use different body positioning for half the day, you cut their exposure and that over exertion to that one muscle group in half if you rotate them around throughout the day. So we'll talk more about that. Work practice controls, just training your people, using proper techniques with lifting. One of the big popular ones out there now is called power lifting. You go at everything to the corner of it if you can, so then you can get it between your legs and lift. Because they always say, lift with your legs. Well, if the object is out in front of your knees, it's really hard to lift with your legs because you can't straddle it. So especially like a box situation, you always want to go at the corner of the box to pick it up, so then you can get your legs kind of around the object as you lift it. And then, look at the work processes. Avoid necessary steps. If you're doing extra stuff, that's more movements, that's more stress, that's more wear and tear on your body. So really try to streamline your processes to minimize, each movement. Break each job down into job steps and look at each step. And can those be made more efficiently for body stress and production? Usually will work both ways. And then once you look at all that, you can do the job training. And, of course, exercise and conditioning leads to a lot of this stuff. Having a good, maybe encourage your people, some kind of gym membership. I don't know how that can work with HR stuff, but, if you're more in shape, usually it's a lot easier. Because a lot of us, we go to work and we go home, we watch too much TV, and we don't exercise as much as we should. And then our body sometimes isn't, our core strength isn't up there where it needs to be. That's where a lot of these injuries come from, is just, you overexert your back and you don't have a good core strength when you're lifting and stuff like that. So, well, medical management, early reporting and treatment, so you can get right on top of things and look at deals and get them, assess if someone's getting sore. It's before an injury, but, I just, my arms just hurt every day. Well, that's a good indication we might want to minimize the risk or minimize that exposure by doing so. Look at the symptoms, medical treatment, your record keeping, your back disorders, your just sprains, strains, ruptured slip discs. One of the theories within safety realm, I guess, is that most back injuries heal themselves in 27 days. I don't know, Now that's all if you guys have seen that, but most of us, I mean, I've hurt my back a few times just through football and through working, different things like that. And, it takes, if you kind of take it easy and you do stretching and different things, usually the pain will go away within a month. So that's always a good thing to keep in mind too. You have muscle spasms, all that kind of medical problems. It's always good to, seek professional help if that occurs, though. So back pain factors, improper posture can lead to that, poor physical conditioning, and then improper lifting, just picking it, bending at the waist and going down. Because our hips and our back muscles and all that works as a lever system, and the more you bend over, the more force, gets exemplified to your ligaments and tendons to lift objects. So that's why it's always good to use your legs so that you minimize that pressure that gets put on your back and that force, and then which leads to the injuries. Proper lifting, you always want to size up the load, bend your knees, don't twist, always go at things straight. And then before you make the lift, though, think of where you're taking the object. A lot of times injuries happen while you're lifting. Once you make the lift, and then you're having to go through objects or step over things and all of that. I know a lot of people don't teach that, but it's, you think of the path. Think of the path you're taking with the load as you're carrying it too, making sure that you don't have other obstacles or have to twist or turn to get through the path. And then always lower things slowly. That's the other half of it. You always want to lift, slowly and carefully. But you also want to set things down very slowly, because the same force is there, regardless if it's lifting up or lifting down. You're still exerting that extra pressure and force on your ligaments, tendons, muscles. And then, you get back to tools, using tools, push carts, dollies, like waist-high type carts, moving stuff around so you don't have to carry. You might have to do initial lift, set it down, you wheel it where it needs to go, and then you set it down, different things like that. Think, work smarter, not harder type of thing. It all builds up. So one of the ways you can look at all this ergonomics is, a cup of water. Once that cup fills up with stress and overexertion and wear and tear, then you have an injury. Most of us will say, oh, I hurt my back. Well, you didn't hurt it today. You probably hurt it in the last 3 or 4 years, and it builds up. And that's why get into the job rotation and why we want to minimize the stress every day, because our body will dump that cup of water out and refill every day. So long as we stay below the level of it, you won't have the injuries. So in summary, we talked about, basically defined the ergonomics, the injuries, risk factors, controls, and medical management, and some of the proper lifting. Well, let's get into kind of what we do here, lumber handling and sawmills. You see this gentleman here, he's got his hand on a piece of wood, so he's handling it. So let's get into this. Ergonomics, we want to, number one, like anything in safety, these are kind of some of the things I try to really stress on with everybody is, a lot of this is a formula, and we just need to change the variables. And so, it's not reinventing the wheel every time. Once you get a good, solid safety culture and you get a nice formula in place, a lot of these things will fit in that formula, so you can kind of pick it apart and solve these problems so that they're not so overwhelming for us. So when we look at this, number one, we always want to identify the hazards. In this instance, identifying ergonomic hazards. And number two is, well, how do we control those hazards? How do we minimize the risk and, and all reducing any possible type of injuries that can lead from not controlling these hazards? Okay, here's kind of the science between what we do here. Okay, a lot of our injuries will lead to, say, like a back injury. Well, where does that injury come from? Where is that hazard? Okay, you can lift things, that's fine, but when you bend your back more than 30 degrees, that risk becomes a real hazard. When you start bending your back 30 degrees to do a job, that's when the injuries occur. So when we kind of look at this scientifically, they've kind of worked this formula out. It's kind of based on an average, so some of us are weaker and some of us are stronger, but on an average, this is kind of where our backs are. If we use our backs, at a bending more than 30 degrees for 4 hours a day, anything more than that, it kind of kicks us up into that next level of it being you're just, of an injury happening. It really increases the hazard of this activity. And then if we increase that to 45 degrees, that means, you're bending, reaching, and all that. That's where it really cuts it down to 2 hours. Anything more than 2 hours of you really bending, you're bending more than 45 degrees, then you really can introduce yourself to more stress, more pressure, more forces that will lead to an injury. So these are kind of some of the things you think about. We talk about job rotation, everything else like that. These are the cutoff points where we want to think about. If you're using your back more than 4 hours a day, meaning you're bending more than 30 degrees or 45 degrees, then we need to kind of look at, well, then that's kind of the cutoff where we should probably do a rotation so they use different muscles. Now lifting, it varies, on the hand placement, the frequency, and the weight. Those are all the factors. If something's heavier, well, if you do it more, then it's going to cause more stress on the body. Now shoulders and arms, gripping every few seconds with a force of more than 10 pounds. So like if a person's grabbing a piece of lumber and moving it, adjusting it, if he's applying more than, this is just gripping, not the actual movement of the piece of wood, but just gripping it, grabbing hold of it. If it's heavy, you're going to have to grab it, with 10 pounds of force to be able to move it, right? Well, doing this activity, they say more than 3 hours per day can really increase the chance of injury, because the gripping and gripping and gripping and grabbing and moving every few seconds, and you're working on a line and you're grabbing lumber, and if you're having to exert more than 10 pounds for more than 3 hours a day, it kicks you into that next level where you're really going to be susceptible to an injury. But if you can keep it below this threshold, then your body should be able to do it day in and day out, as long as you don't go beyond this. And then the thing we talked about before with the bent wrist, you bend your wrist, that increases that force that needs to be applied to do the work. So then you need to lower the exposure to stop you from having an injury. Now, when you're working with your hands overhead or reaching more than once per minute for a total of more than 4 hours, then it'll kick you into the next thing. So if you have to reach overhead a lot, like putting stickers on a load or different things like that, that's where we'll talk about stickers later. But that's where you'll start seeing injuries. When you get away from your belt buckle, basically, the further you go away from move your hands away from your belt buckle, the more force is needed. With more force, more trauma, more stress, which all leads to injuries. So we kind of got to look at that. And your neck. Well, if you're working on controls or if you're looking down, you bend your neck more than 45 degrees for more than 4 hours, then it kicks you into that whole danger zone, where you're more susceptible to an injury. So if you're having to look at controls, you move the controls are down, so you're looking down all the time. Some of us are working computers off and on. That's why it's so important to position your monitor. Same thing goes to working on a line. You're working on a monitor, you're working on a control panel. Well, maybe you can move those control panels. One of the best ways to fix that is move the control panel so it's more in your direct vision, and also so when you press the buttons and stuff like that, you're not constantly doing the same thing over and over. So making your control panels that can be adjustable for different sized people that work on that specific workstation, and also moving them around so you're not doing the exact same thing all day long. You can move it, move it upright, move it down, move it left to right, so it's not always the same repetitive muscle movements that can wear you out. Now, hips, knees, ankles, feet, we all experience that, especially most of these jobs you're going to be standing for long periods of time. So one of the things you can look at is other than being physically fit and all that good stuff, looking at anti-fatigue mats. They'll absorb that jarring and trauma to your hips, knees, ankles, and feet. They make some really neat ones out there that are really comfortable and absorb a lot of that shock. And then also insoles. You can go get some of they got those machines even now you stand on, it'll even tell you what ones you need. I saw those in some of the stores. And then also the 6-inch footrest bar, especially you're standing there on a line, you can put a bar across there that people can rest their foot on. It really changes the posture, which can really decrease the amount of pain and suffering that people go through when they're standing there all day. Just that little differential of a footrest bar. And those are pretty simple to install. I've seen it some places. So that can really help. It just makes you move around. You know, you put your foot up, you put your foot down, you put your other foot up. You know, it's all about, you know, spreading out your activity so you're not constantly just standing there overusing a certain position. Because repetitive, believe it or not, repetitive type movements can be as simple as just standing there all day. Just standing in one position that's repetitive. You're keeping your knees locked, keeping your hips locked. That can be very repetitive, and that can wear you out too. So putting that footrest bar to put your foot on once in a while kind of changes that up a little bit. And then also the foot controls. When you have your heel on the floor and you push your toes up and down, that really can pull on those muscles, ligaments and tendons in your calf muscle and your legs, stuff like that. So there's different positioning of those controls that you can do so that you push down instead of up, or make those adjustable so that you can move them around a little better so you're not constantly using the same foot control and the same foot movements and body positioning all the time, every day, day in and day out. So a lot of this all can be adjusted, you know. So when you make things move around a little bit, then you reduce the amount of trauma that happens each day. These are some of the specific jobs that we're going to look at today. We got the machine off bearers, edge operators, resaw operators, straighteners and drop sorters, trim saw operators, planer operators, graders, pullers, and banders. So we're going to dig into each one of these specifically, look at some of the risks, look at some of the controls specifically on how we can kind of deal with some of these hazards that can hurt our people. All right, the machine off bearer. It's located between the head rig saw and the edger. It ensures that the cants are straightened and ensures that slab woods and slash are disposed of. And these cants can weigh up to 300 pounds. So you can imagine handling the big old pieces of wood cause lots of trauma. Some of the hazards, well, bending, reaching to turn the cants and to remove trim and slash. I was watching some people do this before, and you know, they're having to reach way over, reach out, grab stuff, you know, constantly all day, bending and reaching. Lifting and turning the cants, you know, it's all exposure movements, putting force, movement with force and repetitive type motions. Manually handling, excessive slash and trim, gripping large and heavy cants to turn them. So that gripping motion, you know, you're moving your fingers together to grab things and then move them. That's all repetitive motions. It requires force, requires, you know, kind of some trauma, you know, it can happen. And then looking down at monitors and control panels. Some controls that we can deal with some of these hazards with the machine off bearer are maybe raise the chain. It depends on your situation, what you have. Maybe you've done some of these things already, but these are things just to kind of point out that if you haven't thought of, maybe could be done to reduce some of these exposures. Raise the chain to reduce the bending angle. Use a tool like a pike pull to remove trim and slash so you don't have to reach as far. Use a tool so you can save on the back. Use mechanical board turners or reverse running chains with pneumatic driven pop-up pins or stops to flip boards. Install a controlled gate to stop on head rig outfeed together with jump chains to direct materials. Help your people out so they don't have to do so much manual work. Tilt head rig saw to make sure the weighing of the cants is up. Ramp system to make cants up and allow trim to fall down. You can install a steep unscrambler which will help straighten and separate the boards. Then you can do through training, like administrative type control. It's like train the head rig worker to turn the log frequently and not cut past the center of the log before they flip it in order to ensure proper landing of the cants with the weighing up. Use the momentum of the chain to assist with turning of the cants. Instead of using your arm strength, use the mechanical system to help you along the process. Now the next area you want to look at here is the edger operator. And take a drink of coffee, excuse me. All right, I'm back. You want to make longitudinal cuts in or what they do there is they make longitudinal cuts in the cants. They also they're positioned right after the head rig saw. Cants are broken down into boards and straightened by the edger operator. It manually feeds the edger, and he or she also operates controls, and sometimes this can be computerized. Just kind of depends on your setup at your location. So they do a number of different jobs there. Some of the ergonomic hazards, well, there again, you got gripping of the pieces of wood to straighten them. You got lifting of them to line them up. Then you got gripping of controls, joysticks, using your hands to do these type of jobs. So repetitively using them, looking down at a monitor or control panel, you get those neck issues. So making, some of this stuff movable is very helpful. So other controls, you could raise the end of the feed table to make it higher than the roller and add adequate line bars with reversible chains. You could use a system of pop-up pins to align the cants, so you don't have to do it so much by hand. You can use alignment and jump chains, use a line bar to straighten cants. You can install an adjustable fence. All these kind of things can be done to minimize the amount of physical hand material handling for your people. Also, you can install a surge chain with manual positions. There's all kinds of different unscrambler setups you can use to minimize the human type exposures. Position control panels, so they are adjustable to properly position them to improve neck postures and to account for a variety of people. I'm 6'4". I'm a taller kind of guy. Well, what if the other guy that works my machine is smaller? Well, you might need to move it down, or maybe he's taller. You might have to move it up. Different things like that. Make the controls adjustable. Well, now the Resaw operator, he further sizes the boards as they're needed as they go through the system. Some of the things he is exposed to as far as hazards, he's reaching above his head for the control panel, gripping boards and feeding them to the saw, lifting heavy boards, especially during upset conditions when boards pile up. I've seen some of these pile-ups and jam-ups, and people are lifting, 3 or 4 at a time or even more, trying to get the things unjammed. Some of this kind of things happen, and you got to think of some of these non-routine situations. Well, a lot of times people get hurt in those situations too, because they're overexerting than what they're used to. Just trying to hurry up and get it done so they can keep going. And you got to kind of look at how do we deal with those type of situations. And then bending, reaching for boards, and then of course standing for long periods of time. Some of the controls that we can use for the Resaw operator are, relocate the control panel, to eliminate him or she having to, reach up. Make controls adjustable to improve worker posture, so you're not bending down, you're not throwing your neck down, past that 45-degree angle. You want to automate board feeding processes with pin stops and operator, and the operator sitting in a booth. Maybe you don't have to have a person even touching the wood. It just kind of depends on what kind of setup you have. These are all different things to look at. You use speed up rollers to make sure boards are sent to the operator's position to help reduce reaching and grip force on the boards. Use speed up rollers to make sure boards are sent to the operator's position to help reduce reach and grip force. Use unscramblers to straighten and pace boards. And then you can install a V-notch unscrambler in limited space situations. You could also have an opening to allow the operator to get closer to the long reach while bending. If you can get right up in there and you can reach in there a lot easier, you don't have to go as far. And then, of course, train your workers to wait for the boards to come to them. Don't reach and grab the board. If the boards are coming to you anyways, you might as well wait for them. And then that reduces the angle you have to bend your back and reduces the amount of trauma you experience every day, which can lead to an overall injury. Another job that we do is a straightener or a drop sorter. Some of the other words are floaters or tipplemen. They clear up jam-ups on conveyors. They unstack and straighten boards. They dispose of the debris, sort boards, and operate drop gates to send boards to appropriate chains. Now, some of their ergonomic hazards for the sorters there, you got handling boards, straightening them, sorting them, unstacking them, stacking them, lifting large and heavy boards during short sorting. And then you got bending for boards or slash, looking down at monitors or control panels. Now, the way we can kind of deal with some of that stuff is we can install functional unscrambler with metal crossbars that can help reduce pileup of boards. Unscrambler capacity needs to be compatible with the board flow. Deeper unscrambler is needed with high production flow conditions. So you got to kind of look at what you're trying to feed through, make sure it's kind of all lined up and calibrated so that you can minimize the amount of extra work that people have to do. You can adjust the angle of the slopes of the unscrambler so the boards can be dropped down smoothly without cross-ups. So every little less cross-up is less material handling. You kind of can look at all that stuff. Install a trim eliminator. Position the second conveyor belt before the unscrambler to avoid cross-ups. You can place a picker on the edge of the outfeed to dispose of slash and trim. Install a computerized trim eliminator to get rid of the trim at the edger. And then you can place a chipping head on the edger. Adjust the speeds of the conveyor chains to avoid pileups. Make sure everything's kind of calibrated so as things go through, it's real nice and smooth. And then for visibility and communication and stuff, put mirrors in so you can see pileups and you can identify things that are going on. You make sure a number of operators are compatible with the product flow. If you need an extra person, get an extra person, different things like that to minimize the amount of problems. Another thing too, the more people you add, the less each person is doing, so it reduces the amount of stress on a daily basis. So just so you're aware of that too. So sometimes there can be trade-offs and payoffs to, adding a person. You reduce, the average stress gets reduced every time you add more handlers. And then train operators to handle boards only when necessary. Let the machines do their job. Don't overwork as far as, exposing yourself if you don't have to. And then move operators closer to gates to reduce the bending. Further things are away, the more you end up bending. Now the trip saw operator trims off the end of the boards to length. The load lugs that carry boards into the saws. Some of the ergonomic hazards the trip saw operators are exposed to are gripping boards to position them into lugs, gripping boards to position them for cuts, gripping boards to help straighten or separate them, and lastly, with the gripping slash to manually dispose of it. So lots and lots of gripping, using their hands, grabbing, and throughout a day, that'll wear you out, and especially if you go over the limits. And then, of course, bending and reaching and lifting boards. Some of the controls we can do for the trip saw operator are installing a properly designed automatic lug feeder. We can add an extra powered belt for longer boards to assist with alignment. We can use a curved ramp after an unscrambler so boards coming up will be straight and separate. We can also synchronize chains to prevent pileups. We can automate the process with electronic eyes to know when to load more materials and to detect excess in order to prevent pileups. We can install a drop sorter before the trim saw to dispose of slash. Also, if you increase the space between the unscrambler and the operator, you can sometimes reduce jam-ups because it kind of give you a buffer area so you have a little room to kind of work with the material. So now the controls for the trim saw. You can use a person to monitor backups so that no more boards will be sent to the trimmer than can be handled. And then through training, teach the operator not to handle boards unnecessarily. Install functional even-ending fences to align boards, and chain control training. Make sure people observe the workforce and kind of look at, well, how well is it flowing? Can we improve kind of so things move a little smoother? Kind of looking at some of this stuff to make adjustments. Sometimes little adjustments can go a long ways. I have to have another drink of coffee. You guys are welcome to have a drink of coffee too. All right, well, let's move on to the planer operator. Well, with the planer operator, basically he loads boards into the planer machine. Foot and hand controls are used to advance chains and control planer machine. Moves boards from piles, manually removes stickers, turn boards for inspection before feeding them into the planer. So I mean, there's a lot of grabbing things, moving things, lifting things, all this kind of things go on to keep that planer moving smooth. Some of the hazards, we've got reaching overhead to remove stickers, gripping boards to manually load them into the planer, and gripping boards to move them from stacks. Then also looking down at the monitor or control panels, even looking down at the boards over time can wear you out your neck. So some of the controls that can be used to kind of control these hazards, you can develop a system that removes stickers before they are sent to the planer station. So there's no stickers for them to remove, therefore totally eliminating that job's exposure to that stress. You can install feed rollers at the planer machine to send the boards into the pineapple, and an angle of ramp after the unscrambler is an important consideration to ensure boards are dropped smoothly and not crossed up. V-notch unscrambler may be appropriate for mills having limited space. Adjust chain speed to ensure that boards do not pile up, and then make control panels and monitors adjustable and movable so people can vary what they do, so they can kind of minimize the amount of overall stress they experience in a day. Now let's look at the grader. They grade the boards of various dimensions and weights according to their quality. Well, they're gripping boards to turn them to send them to the resaw. So I mean, they're grabbing them, they're moving them, throwing them, different things like that. Bending can happen. Some of the controls that the graders can use is a mechanical board turning device with a lug loader, install a functional unscrambler to reduce board stacking, and also add another grader to reduce overall exposure to the risk. Just like we talked about before, you add somebody, the more people, the less handling of each particular piece of lumber, and you kind of minimize or you kind of lower that average and minimize the injury risk. Now the puller. Boards are manually pulled off the conveyor chain and stacked by dimension for transport. Well, they're grabbing pieces of wood, they're pulling boards to stack them, they're lifting boards to stack them, they're bending to lower boards onto the cart during stacking, and then they're looking down, so you may have some neck issues. Some of the controls, we can install mechanical sorters and auto stackers. If boards are heavy, train workers to pull only one board at a time, depending on their ability. The more force you add to this equation, the more the risk increases for injury. So instead of 3 boards, just lift 2, Train workers to put one hand underneath the load when lifting and carrying boards to reduce hand grip force. If you can cup the load instead of gripping with your hand, just kind of vary that. It kind of averages out the amount of stress to your arms. Train workers to use the leverage of the boards and momentum during stacking. Use an adjustable height or cart or a bin, so you don't have to bend as far, different things like that, reach as far. Keep it around that belt buckle. Everything you do should be around your belt buckle as best you can. Install a scissor lift to raise carts, bins to improve posture during lifting and stacking, and make control panels adjustable and movable. Now let's look at the bander operator. I think this is the last of our different jobs that we'll look at, specifically anyways. So it bands loads of lumber for transport. It's kind of the end of the production line. Staple guns are used, wrapping tools and wrapping the loads are done here. Well, some of the ergonomic hazards for the bander operator are, using your hand as a hammer to align boards. I've seen it many times. People standing there, that one's a little crooked, or that one, taking your palm of your hand, using it like a hammer. Hitting, striking, just it's a repetitive action. You're causing trauma to your hand, your wrist, all that kind of stuff over time that can cause injury. Bending to, band or wrap a load or, the wood. More than that 30 degrees, then causes trauma. Using a chainsaw to trim the end of the board, so you got lots of vibration. Chainsaws create lots of vibration, which reduces blood flow in your extremities, which are your hands. Reaching above shoulder height to load the magazines, and repetitively firing staple guns. And make sure you wear eye protection, right? Okay. Ergonomic hazard controls. Use a rubber mallet instead of your hand. Use a tool. It's like any of these kind of jobs. Can you use a tool that will minimize the exposure to the people? Use an evening machine so you don't have to, it comes into you already evened out. Automate the process. Do you have to, can you use a machine? Can this be done through some other means so we can remove the exposure that is presented to our workers? Rotate worker jobs that don't include gripping. Replace load on adjustable height stands. As the load gets higher, you can move it up. As it gets lower, you move it down, so you don't have to bend over as far as you're loading. For the vibration, they make some really nice gloves out there that can help absorb their anti-vibration gloves. Raise the loading area. Stop speeding up. Train the operator to load magazine at the lower levels. Elevate workers so they can fill the magazine from higher level. The battens must also be raised. Work with customers to develop a better labeling method to eliminate the repetitive firing of a staple gun. Can we just eliminate the staple gun altogether? I don't know. Band it all up all in one process maybe, and not even use a staple. These are things you always got to step back from our actions, these jobs that we do. Engineering controls. Can we eliminate the exposure altogether? Because if you can eliminate the exposure altogether, you will not have an injury. There's no chance. The risk is zero of an injury if you can eliminate the exposure. So those are kind of things. I don't know, in your production, looking at, can we eliminate it? It doesn't have to be specifically for a staple gun, but, can we eliminate it? Can we change it? How can we do all this? Can we do before we expose our people? And then build or purchase an automatic labeling machine. Just get people totally out of the equation. This is one of the biggest things we want to talk about today, kind of toward the end here, is job rotation. Job rotation, limits the employee exposure to the risk factors. You just totally minimize the amount of stress that a person is experiencing by averaging it amongst other employees. And it reduces the potential for injuries. Now, some of the, pushback, of course, with production and stuff like that, well, this guy knows how to do it. Well, this other person doesn't know how to do it as well as this guy or this person. Well, we want to, keep our production up there, so we don't want to put a guy that's not as good at this, at this position or doing this job. So you got to understand there'll be a learning curve. When someone's new to that job, it's not going to be as good as the person that's been there for 20 years, but we want to make sure that person can be there another 20 years. So through these types of job rotations, we can increase the longevity of our employees, which is our #1 resource. So we want to give adequate training. Don't just drop somebody off. Hey, do this. Give them really good training so that learning curve is a lot shallower. It's not so steep for them. So, take that guy that's been there 20 years doing that one job with the new person and have them spend time together so that they can, this is how you do it, this way you do it, this way, when this one comes in this way, this is what you do. Minimize the amount of stress on that new employee, not only physically but also mentally, so that they can perform and they can grasp the concept of that job and be very productive in the long run. And then, give them, that break-in period of the new person. Give them an opportunity, that, it'll take them time, but once we get all that squared away, we'll all be better off. Now, we want to keep to a minimum in these job rotations, a lot of times to 2 or 3 jobs throughout a day. That allows for people to become experts at their job. If you rotate people more than 3 times or 4 times at a very maximum, it's hard for them to become an expert at their job because they're moving around so much. But if we keep the job rotation of 2 or 3 jobs a day, we can maintain that level of expertise, but also share the load of the stress. We also want to make sure that those jobs are different enough that when you move them around, that they're using different muscle groups and different body positions and different forces and stuff like that, so that it actually can be justified. Because if they're using the exact same hand movements, moving them to different jobs not going to benefit you at all. But most jobs, though, are different enough. Even just hand movements, moving hand up and down versus left and right, you're using different muscles, ligaments, tendons, and you're applying different amounts of stress to the body, so you can diversify the amount of injury and minimizing it, of course. And then the last point there, it says strengthens your team's average knowledge and flexibility. If you have, say, 3 jobs and you move 3 people around, well, 3 people are going to share that knowledge, and 3 people are going to become experts at running those 3 different pieces of equipment or those 3 different job positions. So if one person's gone or retires or something like that, well, you're going to have 2 other people that can step in and do that same job. So it strengthens your team and allows this management to have flexibility in moving people around. So in the long run, once that initial, training or break-in period or that learning curve has been overcome, you'll have a very diversified knowledge base within your workers so that you can really run smoothly production-wise. So some of that can all play into, so you can benefit from reducing the exposure, reducing the injuries, and also increasing the flexibility of your personnel. One of the last things I want to talk to you about today is we have an Ergonomics Grant from OSHA that allows us to do training and do specific ergonomic type activities for our members. And what we're going to be doing here in the near future is probably soliciting some help from you guys to actually get us out there to do training to satisfy the grant. In return, you'll benefit from the training, but also we'll have to do some needs assessments, do some job position, kind of like what we talked about with the different jobs there at the sawmill. We might want to go out and kind of build upon some of this stuff. I want to get out there and verify a lot of this stuff and make sure some of these things, these controls that I talked about today. I mean, I'm sure it's a short list compared to what else can be done, and maybe some of them are wrong. I mean, some of that stuff. I mean, we want to be able to make this controls, hazard controls, a lot more solidified and a lot more variable. Well, what about this job? Well, okay, well, let's look at this job. Let's see what we can do to benefit all of our workers. So that we'll be doing that in the near future. Satisfy the grant requirements and provide you all with the service. With that in mind, I'd just like to thank all of you for joining us for my presentation on timber ergonomics. I hope it helped you a little bit. If you have any questions on any of the topics that I talked about, or if you want to kind of look at some of these controls, please send me an email, give me a call, and we can kind of go over some of these things. How will some of these controls specifically fit your work environment? And we can kind of work on those things so that we can reduce the risk of a potential injury, and so that our workers don't have to go home in pain. I mean, a lot of our ergonomics can really benefit just the overall happiness of our employees, because yeah, there might not be an injury where they're going to the doctor, but going home every day and being so sore you can't do anything but watch TV, that's not a very good quality of life. So that's what we want for our people. And through this ergonomics techniques, we can improve the quality of life of a lot of our workers so they're not in pain and they don't suffer so much with type of musculoskeletal type injuries and different things like that. So it's all about, kind of looking at exposure a lot of times. Can we move some of these people around to minimize the exposure to one specific type, repetitive, high force, awkward type position job. So with that in mind, I will close. Once again, I'm John Zeman with Timber Products Manufacturing Association, and I look forward to serving you in the future. If you guys need any safety help, please contact me or Chris Chathams, and we can take care of you. Thank you so much, and there's my contact information. This will be recorded. If you want to pass this along with anybody else within your organization, we'll have that on our website. And thank you, and have a great and pleasant day.